This is number 3 of 2007 FRQ, still in the calculator section. All right, so the functions f and g are differentiable for all real numbers and g is strictly increasing. Okay, the table above gives values for the function and their first derivative at the selected values of x. Function h is given by f of g of x minus 6. All right, so we're going to have to use that. So explain why there must be a value r for between 1 and 3 such that your y value, your h value, is going to be -5. So when you have an interval and you want to prove that your y value must hit a certain number, you are looking at using IVT, intermediate value theorem. What intermediate value theorem is saying is that here's a continuous function. If you know the beginning, all right, if you know the beginning, you know the end, somewhere along the middle you must pass through a number you want. So if the number I want is -5, I just need to prove that my y value is going to be lower than -5 and higher than -5 in this interval. Therefore, because it's continuous, it must pass through that -5 value. All right, so easiest way to tackle this is to look for h of 1 and h of 3 and see if those two values are sandwiching your -5, and you have proven it using IVT. All right, so this is part A. H of 1. What is h of 1? Well, following the formula is f of g of 1 minus 6. So f of g of 1, looking at my table here, g of 1 is 2, so f of 2 minus 6. F of 2 is 9, so 9 minus 6 gives us a value of 3. Okay, good. H of 3, f of g of 3 minus 6. So what is g of 3? G of 3 is 4. Okay, and then f of 4 is -1, -7. All right, so see, one y value is 3, one y value is -7. So somewhere along the line, I have to go through -5 to get from 3 to -7. So I will say by IVT, just by these two values and you quoting IVT, that's enough to prove this. So by IVT, there exists a value r such that h of r is equal to -5. Yeah, h of r, h of c, same idea. You don't really have to use r if you are not comfortable with the letter r. Okay. All right. Next, part B says, explain why there must be a value c between 1 and 3 such that h prime of c is equal to -5. So this is where you use MVT. MVT is mean value theorem. What it is saying is that I am looking at the instantaneous. So to quote physics, you're looking at when the instantaneous velocity is equal to the average velocity. So again, easiest way to tackle this is to find the y values at those points, find the average or the slope. So you're looking for the slope, the overall slope to equal to the instantaneous slope, right? So let's take a quick look at what that gives us. So where do you have h of 3 and h of 1? So the average rate of change is going to be h of 3 minus h of 1. So y2 minus y1 over x2 minus x1. We already have the two y's from before. So -7 minus 3 over 3 minus 1. That gives me -10 over 2, -5. See how that's equal to -5? So my average rate of change is -5. So by MVT, by mean value theorem, we have definitive, we can prove the fact that the average velocity will equal to the instantaneous velocity, right? Just like when we use the idea of taking a road trip, that your average velocity is 60 miles per hour. You must hit that sometime throughout your trip. You won't be on that speed constantly, but somewhere along the line you will hit that speed at least once or twice, or many, many times, right? So by MVT, there exists a value such that h prime of c equals -5. Because we have the average already equal to -5, then the instantaneous will also equal -5. All right, part C, let w be the function given by w of x equals the integral from 1 to g of x, f of t dt. Find the value of w prime of 3. All right, so what does this mean? This is when I said there was a really cool formula that you guys should really memorize. It's when you are taking d dx of an integral from value a to b, f of t dt, because the derivative kind of cancels out the integral. But don't forget, because you're taking a derivative, there is a chain rule there. So you go ahead and take your values and plug it in, f of b, but don't forget b has a derivative of b prime minus f of a prime. All right, so we're going to use that here. So for part C, what is this really asking us to do? Part C says we are looking for w prime of 3. So let's look for w prime of x first. It's a little bit easier that way. W of x equals integral 1 to g of x, f of t dt. W prime, meaning take the derivative, right? This is where the formula comes in really handy. So that means plug it in. So f of g of x, don't forget g prime of x, right? Minus f of 1 times the derivative of 1, which is 0, which is awesome because that goes away. All right, so now that makes it a lot easier for us. So if we're looking for w prime of 3, so w prime of 3, that's equal to f of g of 3 times g prime of 3. Again, using our chart, I'm going to have to cover this up a little bit and go back here. So g of 3 is 4, so f of 4, g prime of 3. G prime of 3 is 2, so g prime of 3 is 2. F of 4 is negative 1. My final answer is going to be negative 2. And that is my final answer. Okay? All right. Last but not least, part D. Part D says if g inverse is the inverse of g, write an equation for a line tangent to the graph of y equals g inverse at x equals 2. All right, so we're looking for g inverse, right? We're looking for g inverse of 2. What does that mean? So using the idea, let me cover this up a little bit. All right, so what does this mean? It means that if this is the x value of g, then g of what gives me 2? Because the x value of g inverse is the y value of g. So let's take a look at g. When do I get 2? Oh, g of 1 equals 2. So g of 1 equals 2. Therefore, the inverse is 2. G inverse of 2 equals 1, right? And then that formula says g prime of c. So we're going to quote the inverse formula. G prime of c equals 1 over f prime of g of c. All right, another formula that I said was really, really handy. Okay, so if we want g prime of c, we want the derivative at 2, and that's equal to 1 over f prime of g of c. So it means that it's going to be a little bit tricky because we're using a lot of g's in here. All right, so let's see if I can write it correctly. I want the inverse prime of 2, right? I want the inverse prime of 2. That's equal to 1 over the original function g prime of the inverse of 2. Okay? So again, as long as your notation is correct, this is not going to be so hard. So it's equal to 1 over g prime of, we already figured this out, this is equal to 1. So using your chart from above, g prime of 1 is 5, so my answer is going to be 1/5. All right, so how does that help us? We want to write the tangent line, so this is my slope. So the tangent line is y equals m, oops, not 1/2, sorry. You want the slope of 1/5 times x minus, well, my y value, this is going to be the tangent line to the inverse. So my x value is going to be 2, my y value is 1, so x minus 2 minus, oh, plus 1, sorry. Because if you're using the point slope formula, it's going to be y minus 1. So y minus 1 equals 1/5 x minus 2. So either this equation or this equation is okay. All right? Okay, that's it for number 3.